HClO2 is 1.2 times 10 to the negative second. So HClO2 is a pretty strong acid. It almost makes the strong acid classification, but not quite. It's not like that. All right. Now, given these numbers, now I want you to rank these in order from weakest to strongest. And if you think you had it before, take a look again. Talk it over with nice people around.
So that means HClO2, that means
Oh gosh.
How do you rank
for every one, like, H plus ion, it has 1.2.
Oh, that's not what the K tells you. K tells you the ratio of products to reactions. The two products multiplied divided by the reactant.
So the products of HClO2 are H plus and ClO2 minus.
Okay, so it's Cl
So,
minus, then H2O.
We have,
Then Cn minus.
so that means we have a very small amount of it.
Of that. Because much of it has associated. But this K is still less than 1, so there's still more reactant.
So technically the value of like the reaction weakest of HClO2 to
Cl, and then it's
Yes.
Why? It's against the 1 times 10 to the negative 1.
So when that dissolves and associates, that's the ratio of products to reactions.
smaller.
K always is.
That means you could dissociate your
Yeah. Now we're talking about these things as bases.
Oh, this is for acid.
I just want you to grapple, and then we'll talk about it. So it's okay to grapple.
What?
I got you, Sean.
Which one? They're all whoa, Cl negative? Really, it's not. If the Ka of this thing is infinity. Yeah. But all we're doing is ranking, so if you don't think that's a base, then make that 0. Or number 1, that's the weakest.
This one?
Yeah.
And I think you're on the right track. That's nice.
Oh, the broke.
Look at it. I love it
Cheap
when
goods.
they click it. It was like, oh. No, my dad gave it.
All right, gang, do you have them ranked confidently?
Yeah. I got it.
Yes.
I know I got 100%.
Ranked, but that's it, huh? All right.
Bro, that's how I had the same ranking the first time, by the way. You said I couldn't do it.
I didn't say you didn't have it right.
You said
I just didn't want you to be too confident yet. Would you agree that the strongest base has the highest KB?
No. Wait. No, it has the lowest.
Lowest.
No. The
The
highest.
strongest.
The strongest one is going to have the highest KB because it makes the most hydroxide.
Oh, yeah.
Lowest
I
Ka.
thought you were talking about acid.
No, I'm talking about KBs. So I've got the Kas of their conjugate acids. Can we figure out the KBs then of these bases and just rank them according to their KBs? I think we can. We can because of this thing.
Yeah, but we don't know KW.
No, we do.
Yeah, that's a constant number. It's up here.
Oh.
Yep. So don't keep playing the "I wasn't here" excuse. That's old. All right. So KB for cyanide is KW, which is 1 times 10 to the negative 14th divided by 6.2 times 10 to the negative 10th. And that's going to give us, anybody have it? 10 to what power? Yeah, you could. You could.
To the negative 4.
It's not quite negative 4, it's negative
3.
1. It's
5.
negative 5.
5.
Yeah.
Yeah, because it's 6.
Now, what is the KB for the chloride ion?
Negative infinity.
It's KW over infinity,
0.
which is what? Any number over infinity is 0.
Not necessary.
So this for sure is going to be 1. Any finite number over infinity is 0. What about water?
Wait, 1 as being the strongest?
We're going from weakest to strongest, so this is going to be the weakest.
Wait, but if there's more O, shouldn't
That's acid.
well, that's acid.
Oh, you just want to go based on number of O's? Yeah, no, don't do that. Don't do that. Okay, so then water's KB is 1 times 10 to the negative 14, just like its Ka is. Remember, that's an oddball. You're not going to figure it out. It's just 1 times 10 to the negative 14. All right, now what about ClO2? That would be Kw divided by this number, 1.2 times 10 to the negative second, which is going to give us like 10 to the negative 13th power. It's 8 times 10 to the negative 13. So this is our weakest base. Which one is the second? Who's going to get number 2? No.
Oh.
What?
Come on, Sean.
Oh, my bad.
This is smaller than that. And then we're going higher, and so this one is next. Mina, you got those, right?
Yep.
4, 1, 2, 3. Because HCN is the weakest of all these acids, therefore its conjugate base is going to be the strongest of all those conjugate bases. The strongest of the acids is HCl, therefore its conjugate is the weakest base. Yeah?
So HClO2 is a weak acid? Even though it has
HClO2 is a weak acid.
Even
It's
though it
not.
has all those
Yeah,
O's
yeah,
in it?
Otherwise,
All those O's, what about HClO3 and 4?
Right, but HClO2 should be, I mean, it has
All 2 of those O's? Give me a break.
plus the Cl.
So what?
Plus the H.
No, not
Yeah,
plus
so
the
you
H.
can see, because it's got all that electron density pulled away from the hydrogen, that's what makes it so strong.
That's what's kind of weak for KH.
Write it down, Achuth. I'll read it later. I want to show you what the Zoom dolls have for you to look forward to. Numbers 41 through 40, oops, through 44. Maybe you were trying some of the problems and you got this far and you saw, using table 14.2, which is a Ka table, rank these acids from strongest to weakest. So they're going the other direction, strongest to weakest. But yeah, I mean, all you're going to do is find the Kas of all 4 of these. They're all right on that table. It's a super easy question. I don't remember if that was assigned. Yeah?
oh, no.
Don't worry about it. This is how you do it. Now, number 42 is like we just did. ClO2 negative, we did that one. H2O, we did that. And then they threw a couple different ones at you. Rank the order of those bases, how strong they are. And then in number 43 and 44, they're just asking you to compare the strength of, like, which is stronger, HCl as an acid or water as an acid? Don't get that one wrong. B, which is a stronger acid, water or this weak acid?
Not sure.
Water.
The weak acid.
Water.
The weak acid. If it's a weak acid, it's going to be stronger than water. Water is really, really weak. 10 to the negative 14th?
Is
It's
that
terrible.
the weakest? Or is there even weaker?
There's probably things that are weaker than water.
Really? Like HCl.
Like alcohols, they're probably, they can release a hydrogen, but they're very weak.
Wait, how is it really weak? Is it just neutral? It's not basic or acidic.
Oh, is CL weaker? HCl?
Well, yeah, I mean, you can define it as acidic because it gives off a hydrogen ion. What's that? You did that one? Okay, good. So anyway, now, I think Jennifer, or one of you, which one was it, that was asking me about the organics? Was that you at the beginning of the hour? Like, here's an organic. This is actually phenol. This is a benzene ring with an OH on one of the carbons. What would you consider this thing? Is it an acid or a base? What do you think about doing there, Mina?
I said it was an acid because it had.
No, you're not going to throw anything in class. Like, this is not ghetto class.
Who throws carrots, man? It's cool.
I said it was an acid because it was a. Oh,
It's an acid, right. You need to have the nitrogen in it to be a base. So if you have CHs and Os, then it's going to be an acid.
So is nitrogen the only thing that would make it a base?
Yep.
That's easy.
All right, so 41 through 44 asks you to do this ranking business. And then like a bad infomercial, wait, there's more. If we turn the page over to the 80s, look at 87, 88. Yeah. They're referring you to another table where they'll ask you to compare which is stronger with these sets of compounds. So yeah, there's lots of this comparing to do. And just look at, if they ask you for the stronger base, go to the KBs and compare the KBs. The higher KB is going to be the stronger base. Yeah?
What is 87C? What's the stronger base? OH minus? Always trying to
What would be the KB of OH minus?
infinity. No. 1 times 10 to the negative 0.
It would be 1 times 10 to the positive 14th going that way.
Oh, when it's compared to water. So not just OH and then
Right.
NaOH.
Yep.
No,
Yep.
do not touch my eraser. This eraser is
Okay, let's see. I got one more problem for you. And this one may catch you by surprise. It appears to be a strong acid problem. I think it is. Answer this question. Calculate the pH of 1 times 10 to the negative 11th molar HCl. And then ask yourself, does my answer seem reasonable? Let me give you a minute.
a strong acid. If it's a strong acid, then I'll have a low pH.
Yeah. Complete dissociation.
So can you use a 5% reaction? Wait, can you go over 5% rule one more time? Is it just like 5% rule where you take X change?
Yeah, if X is really small, then when you have to subtract it from something, it just
But it doesn't work the opposite way where it would be like, oh yeah, no. You said that was the opposite. Were you assuming
Yes.
Negative.
Strong acid. Ka is infinity, which means it completely breaks apart. Right? So our chemical equation is going to look like this.
Well, what about H? You don't need H.
So then the change is 1 times 10.
Because it's a strong acid, you see that arrow? I try to make it obvious. It goes to completion that way. So this is going to be 0 at the end, and that means it had to go down by the entire amount. Right? And that means that the hydrogen concentration, 0 plus that, would be 1 times 10 to the negative 11th molar. Right? Is that what we're trying to do here? And so we want to know what the pH is. So you want the negative log of the hydrogen concentration, and then there seems to be something funny about that. That's why I always warn you, hey, check your answer and just make sure that it seems reasonable. Is it reasonable to think that if you take a strong acid, hydrochloric acid, and put it into pure water, that somehow it could give you a pH of 11?
Is it?
Maybe.
Should it be 3?
Yeah.
Should it be 3? Like 14 minus 11? How could this be?
It's such a small number, the molarity is very small.
Yeah.
It's a very small molarity. It's so small that it's like stupid small.
Yeah.
Right? It's a dumb number. 10 to the negative 11. It's like if I took a bottle of HCl, concentrated HCl, and I dropped 1 drop in our school swimming pool. I'm like, stay out of the pool. It's acidified now. Don't go in there.
It's okay.
Turn it down.
Assuming it was pure water. That's kind of what this concentration would be. 10 to the negative 11th molarity. Give me a break. Okay, now, still though, would you expect the pH to be 11?
No.
11?
It should be very close to 6, like right below 7.
Okay, now, I am making an assumption when I do this this ice table. For the first time though, my assumption is bad. What assumption do we make when we make these ice tables? No, because that comes in later.
Then it goes up by the same amount.
No, because it does. These both go up by the same amount. There's another.
Because it disassociates.
That is starts out with 0.
Right, Wesley said it.
Starts out with 0.
We're assuming that H plus starts at 0. Does pure water have 0 H+ ions in it?
I mean,